You have a talk that looks at open source hardware. How is that different from traditional hardware?
To be honest with you, it's not different at all. It's the exact same hardware, it's the exact same technology, the exact same components. What is different is that the design files in a digital format are shared. So if somebody buys a piece of open hardware, the expectation is that the plans, the files, the CAD documents, all of that is accessible.
Okay. So the output is the same, but the source files is accessible to everybody.
Correct.
Is that right?
Correct.
How do you feel that open hardware will shape things like the new hardware movement and the Internet of Things?
I think open hardware is an important part of what's transpired in the maker movement, also in the new hardware movement. A lot of startups that are kickstarting projects have based the starting technology on open hardware. Mm-hmm. So there's a lot of infrastructure that exists in open hardware that people have been able to build on and do some very innovative work. So what happens is it saves you a little bit from having to reinvent the wheel. You can use the kind of work and input that other people have generated and have a much more efficient, effective, and low-risk starting point for whatever it is that you're building.
What was your motivation for getting into open hardware?
Really just being part of a community of people who were working on a lot of interesting projects, a lot of interesting hardware projects, and just trying to share what we were doing. So I worked for a number of years as an engineering consultant and had a lot of clients where I'd do some really crazy projects, but I couldn't share what I was doing at all. And then I saw people in the maker movement coming along and saying, hey, look at this little board I put together. And I looked and said, wow, that's pretty pathetic compared to what I was doing. I could really bring a lot more power and more powerful tools to this community if I was working on things that I could share. So I took a lot of my personal projects and started to share them with friends, open them up, and a lot of other people did the same. So for me, it was really an opportunity to engage with people who were interested in working on some of the same things I was interested in working on, but each one of us had contributed a different piece. So you combine all those pieces, it means that I don't have to build my circuit boards starting at a very, very low level with design files. I can use a module from someone else, combine that with some modifications I make, put those pieces together, and then manufacture it, but also at the same time share what I've done so other people could build upon that.
You mentioned opening up previous projects. What is the process for that? Is it simply changing the licensing around it?
Really, it's going through the project, cleaning it up a little bit so that it's in a form that I want to be publicly presentable, and then putting a license on it, because most of the work is completely closed and proprietary, so there is no license. It's not something that would have been shared. So typically for work that has been done for a client, that's not possible. But when I've done my own internal tools, whether they're hardware tools or combined hardware-software tools, I can take those tools and put them out in the world so that other people have access to them.
What's your take on the term Internet of Things? I know that could be a loaded question.
Yeah. Well, really, I understand why we have the term. I think in 10 years, people will look back and it'll just be the internet.
Right.
You know, and I think we see that with a lot of other technologies, with telecommunications. There was the cellular network, and there were landlines, but now it's just making phone calls. Mm-hmm. So those distinctions that we have because of the paths that technology's taken to get to where we're at, those distinctions tend to go away as the technology becomes very commonplace, very commoditized. And I think we understand the Internet of Things to be really devices talking to other devices, where the products that people buy that are connected to the Internet of Things, instead of being products where, like, I'm sitting at a laptop, I'm on the Internet, I'm interacting with the Internet as a human user, it's I've got some device that's on the Internet, connected with the Internet, interacting with another computer on the Internet. And really that's the only fundamental distinction that I see. And I think as time evolves, because that is the trend, that will be many more devices working in that fashion than humans sitting at computers on the Internet. I just think that the distinction between Internet of Things and the Internet will slowly fade away.
So it's just an interim term.
It is. It is.
You've also been doing some work recently about frictionless frameworks. What are
those? A lot of what I've seen take place in the hardware movement is a facilitation of some very complex projects through powerful tools. On the mechanical side, we see tools like SolidWorks, Pro-E, Autodesk has released a number of tools. On the electrical side, there are great tools like Altium and Eagle that people are very, very actively using that allow them to do things that used to take teams of 20, 30, 40 people to do before, and also allows them to do sophisticated work in a much more compressed time frame. And those tools and some of the technologies that are created through those tools encapsulate and embody a lot of intelligence. They're somewhat expert systems where the years of human knowledge is built into these abstractions that are very intuitive for people to use and very powerful at letting somebody express an idea as a physical object. So I can go from idea to creation quickly, low cost, not a lot of risk, not a lot of time. And if you look at those technologies, there's a DNA that strings them together, that connects them together. There's a common design criteria that you can distill out of these tools that are effectively amplifying the capabilities of designers, that are removing some of the barriers for designers, taking a design from their imagination to the physical reality in a short time frame. And I've classified those tools and those technologies as frictionless frameworks because in the simplest form, they reduce the friction of taking these projects from start to finish. And they are frameworks because there are no hard and fast rules about what these tools are, but there's a general set of understandings of how humans work, how our brains work, what constitutes intuitive interfaces. And we talk a lot about that like with software development, but we don't talk a lot about that with the actual products, with the tools, with the hardware that people are using. Arduino is a good example of something that's a frictionless framework, where I used to need about a week to get an LED blinking from a new development tool. And people might laugh at that, but when you look at some of these tools, like you download the Eclipse environment, so you've got a 1 to 2 gigabyte download for your IDE, plus all the libraries that you need to configure a processor. So if I'm using like an ARM 7, for example, there's a lot of components that I need to download before I can get software compiled to run on that chip, plus the hundreds of pages of databooks that you have to look through to understand how the chip functions, how to do something as simple as configuring an output to turn on when you write to a register is not a simple thing with some of these microprocessors. So Arduino took all of those base level systems that people use and a lot of the activities that people did and said, let's abstract this to the level of a designer instead of having it be abstracted at the level of an embedded programmer. And that abstraction and the sensitivity to how a designer wants their tools set up so that they can think at the level of design instead of having to think at the level of memory and logic and registers and compilers. Those sorts of abstractions, I think, are part of the DNA of frictionless frameworks, and also accessibility. So tools that tend to be cost prohibitive become not good frictionless frameworks, but obviously open source software, a lot of the lower cost software tools that people can add upon, build upon, modify, customize, they end up getting shared out in the world as frictionless frameworks.
Last question for you. What people or projects are you following these days?
That's a really interesting question. I'm pretty absorbed with my own projects, which might sound a little bit selfish, but
it's a good answer.
I have a number of very, very demanding consulting clients right now, so that's been keeping me busy. But
laser focus.
Yes, that's very laser focused. But there are a couple things I will mention that I think are really exciting. One is a product from the company Altium called Circuit Maker, which I've started playing with a little bit, and that's a product that they're hoping will transform the way people design circuit boards and design Internet of Things products, where they can encapsulate more and more of the knowledge of designing these products into the actual design tool itself. That's a cool one. I am a big fan of something called LabVIEW from National Instruments, which is graphical programming, which makes most programmers cringe. But what most programmers don't appreciate is that for engineers who are not programmers or designers who are not programmers, sometimes text-based programming can be very intimidating and not intuitive. So LabVIEW is a very intuitive tool for people who are spatial more than they are text-based with designing systems. Another project that I think is really exciting, and maybe these are more products than projects, but these are some of the tools that I've been using that make my life easier. A product called the Other Mill from the Other Machine Company that is a machining center in a box. It's about a 1-inch cube, and it's so easy and seamless to take a circuit board design, put on Other Mill, and within an hour have a very, very sophisticated circuit board come out. That's been my most used tool in the last 3 weeks.
Great. Well, thanks so much for being with us. Appreciate it.
Thank you very much.